So I'm going to be talking about PowerShell 7 today, the state of PowerShell as we've sort of transitioned from open source or from Windows and Windows PowerShell and being a closed source proprietary, .NET framework based application to being fully fledged cross-platform .NET Core Linux ported shell. So here we go. Quick note about me. My name's Joey. I'm a senior program manager who works on the PowerShell team. We are a lot smaller than I think a lot of folks realize. We only have about 11 engineers and 3.5 PMs, and that's spread across a variety of open source projects, including PowerShell 7. We have PowerShell Gallery, which is our equivalent of our sort of NPM or PyPy kind of community module repository. We have a Visual Studio Code PowerShell extension. They're going to be showing some of this stuff in that's backed by a language server editor services that has been generalized to a number of other languages. We've got a static analysis tool called Script Analyzer. Given that PowerShell is an interpreted language, it's a little tricky, sometimes not quite as static as a lot of other lint tools are, but gives you best practices and is well integrated with that Visual Studio Code extension to give you all your little squigglies and warnings. We also own a fork of the OpenBSD Foundation project, OpenSSH, that we delivered into Windows and that PowerShell is strongly integrated with today. PS Readline, which is our interactive experience, gives you colorization, tab completion, those sorts of things. PowerShell Get, which is our package manager, and many, many more. We have our own organization on GitHub, and I encourage you to peek into the projects that we host there. We offer a lot of time to the team to work on, sort of 20% type projects as well, and so you'll see a number of innovations come up there that are all open source, and everything I've put down here, with the exception of the PowerShell Gallery, is fully open source. So, quick history lesson, Windows PowerShell 5.1. This is the latest version that ships inside of Windows. This is typically what people think of when they think of PowerShell as this sort of blue window, the Windows shell that's kind of different from the way everything else works in the Bash and POSIX world. This is denoted by PowerShell.exe. And we've topped it out at version 5.1. So this is, it's also built on .NET Framework. You'll see here this PS edition is marked as desktop. That implies that, this is a .NET Framework-based edition and is essentially done at this point, right? We are supporting it and servicing it, and very similar to CMD, it's likely something that's never, ever, ever going to go away. But we've sort of left it in Windows to make sure that these workloads stay stable, but it's not where we're doing our innovation. It's not open source, and it's not sort of the future of PowerShell going forward. So in August of 2016, we announced PowerShell Core 6. This was based on .NET Core instead of .NET Framework, and this allowed us to move to a cross-platform set of environments. So, where in the past we only supported versions of Windows, we now support Linux and Mac OS. We aggressively expanded the distros that we supported, obviously limited by what .NET Core has supported. But we focused here on really interacting with cloud APIs primarily. We knew that there was sort of this shift from systems management, which Windows PowerShell really excelled at in bringing all these different Windows APIs together, towards somewhere where we knew that the world is now speaking REST and JSON and these cloud APIs. We also wanted to be interoperable in a number of other ways. So this is when we added SSH-based PowerShell remoting. So anybody that may have been familiar with the old WinRM-based remoting in Windows PowerShell, that's still there today in PowerShell Core. But this SSH-based remoting essentially works similar to other SSH subsystems like SFTP, where PowerShell gets registered as a subsystem and then allows it to plumb sort of a richer remoting experience that PowerShell users are used to over an SSH-based channel and with SSH authentication and authorization. We also had to make a number of cross-platform changes. The bulk of breaking changes that we made to PowerShell were in the 6.0 timeframe, and primarily this was around things that we had to do in order to be fully interoperable with non-Windows machines. So you can think, for instance, we had to make a decision on whether to universalize on forward slashes or backslashes, right? And we said there that, oh, we're gonna be really smart and allow everyone to use both, but make sure that tab completion respects the platform that it's on. Those sorts of things. Dealing with native utilities, the piping of binary data, that sort of thing. So it was really all the big bulk of changes that we wanted to make to set ourselves up for success going forward with this new fork of PowerShell. So within this 6 timeframe, we had these 3 minor versions that we released. So with 6.0, we had this focus on, a big aspect here was actually the infrastructure that we needed to build, test, and deploy, release PowerShell in the public and in open source, and as well as how we were going to sort of govern contributions and changes coming in. We had to, again, extend this thing to support, Windows, Linux, Mac OS. These REST and JSON improvements were very substantial in 6.0, along with the SSH-based remoting, but that did continue on through 6.1 and 6.2. With 6.1, we sort of ping-ponged here. So, we got to support the Linux folks, and then we got to go make the old Windows folks happy. So, there's more of this focus on backwards compatibility. .NET Core really expanded the set of APIs that they supported to conform with .NET Framework. We also expanded our platforms pretty aggressively. So as .NET Core grew into the Alpine space and the ARM space, we followed suit. We deployed a number of Docker containers that have been very popular in the CI/CD space, especially for cross-platform app developers who are looking to write the same set of build, test, and potentially deployment scripts regardless of the platform that they're on. And so it's allowed even a lot of other open source projects to sort of coalesce on this single scripting language. And this has been pretty popular with .NET Core SDK users. 6.2, we sort of pulled things back a little bit. We realized that, our small team of 11 engineers, probably half of which at any given time are actually working on PowerShell. We really needed more automation investments in that public infrastructure. And so, we invested pretty significantly in sort of allowing ourselves to accelerate and following milestones. But we also supported, a few delighters. We got PowerShell working well as a login shell, which was a little bit difficult given our lack of POSIX compliance. But we also, enabled these experimental features, and that allowed us to accelerate our innovation as well. So, we could check these things in that potentially we weren't necessarily going to take from a governance perspective, but that we could try out. And you can just think of these as like, Chrome feature flags kind of thing. But, this is sort of set the stage for us to take more aggressive changes and to, potentially play with breaking changes that might otherwise scare us. So PowerShell 7, this is our newest GA product. We actually released this thing last Wednesday, so March 4th, as our final GA. This was our move to .NET Core 3.1, which brought back even more significant round of existing Windows APIs, including WinForms and WPF on Windows. And it also is a time for us to drop the core naming. So we've now said that, hey, as a viable Windows PowerShell replacement, we think we've reached a certain level of backwards compatibility with Windows PowerShell. We've also introduced this compatibility shim layer so that if you're on Windows, we'll actually call out to Windows PowerShell automatically under the hood if your module is incompatible with PowerShell Core. But we've achieved a very large number, somewhere between 80-90% backwards compatibility, with a couple of the teams around our core modules. So Azure AD, Exchange Online, SharePoint Online, we're still closing up the final tail of native compatibility there. But ultimately, we see this as the one true PowerShell going forward. .NET or Windows PowerShell 5.1, has been parked. And so, we've said, hey, let's unify the branding here and just get everyone on the same page that this is really the one true PowerShell. So with PowerShell 7, we also introduced our first long-term servicing or long-term support release, depending on who you ask. This means that we are supported under .NET Core's 3.1 LTS. So they're sort of doing a TikTok pattern now where they'll ship an LTS release 1 year that is supported for 3 years, and then the following year they'll ship a current branch or active branch, I think they're calling it, that will be supported for a shorter period of time. And so because we are more and more aligned than ever to the .NET Core team, going forward, we're going to align our releases with them. We're aligning our support structure with them. And so PowerShell 7 is going to be supported for the duration of .NET Core 3.1 support lifecycle, which is currently until December 3rd, 2022. We will continue releasing previews of 7.1 every single month, starting in a couple weeks. And that's sort of our commitment to, a preview cadence is that we are always putting out preview branches every month or so, with a release coming in the end of the year. PowerShell Core 6 is essentially getting cut off here, so we're not going to support it in any capacity after September of this year. And so for all of you or any of you that went on that journey with us, we appreciate it. But PowerShell 7 is really what we want everyone to get to. For folks that might be worried about upgrading or something like that, PowerShell 7 is in name a new major version, but while we follow semantic versioning in our module versions, with the sort of major PowerShell runtime, the version is somewhat arbitrary. 7.0 is effectively a very, very heavy 6.3. But this just gives us a chance to get everyone on the same page and kind of coalesce around this new brand. So going forward, we'll continue, as I said, to align with .NET. PowerShell 7.1 will be based on .NET 5, which is coming out in winter or sometime December-ish. 7.2 LTS will be based on .NET 6's LTS, and we'll continue forward in that cadence. Now, this one I hopefully will get a chance to show here at the end. But we've got a number of these modules that are fully natively compatible in PowerShell 7. But for those that are not, as I mentioned, we've got this compatibility layer. So there's something in PowerShell called implicit remoting. And basically this allows you to remote to another PowerShell session, which may or may not be on the same machine, and then sort of project a set of proxy functions onto the session that you're currently in, and that those proxy functions actually get executed on the remote session. You can imagine, a highly incompatible module. Like I said, one good example is the Azure AD module, Active Directory. And if you import this thing using this compatibility layer, we'll essentially give you these shim commands in your local PowerShell 7 session that are actually being executed by a local Windows PowerShell instance under the hood. The important thing to note here is that this compatibility layer is unfortunately not particularly useful to Mac and Linux users, and is probably not relevant in the WSL space. But for those of you that are remoting from a WSL box and into a Windows Server box to manage things, this is going to give you just an extra layer of assurance that if you're coming in through a PowerShell 7 front door, that those things that may not work yet today natively can still execute under the hood. Awesome. Let's get into it with demos. I'm screaming along here. So as I said, unless I magically, well, no, because I don't have PowerShell installed in my WSL instance. So as I said, unfortunately, I'm going to show these here in VS Code. You'll notice here, one of the awesome things is that, so normally PowerShell would open in this PWSH, terminal, or I might have PowerShell, not WSL, VS Code would open in this terminal here. This is just the standard Visual Studio Code terminal, right? I can execute any of the shells I want in this thing, CMD, but this one's not going to be as interesting to us as PowerShell users. So I'm actually going to exit out this whole stack of shells, and you'll see here that I'm actually running in the PowerShell integrated console. And this comes from a VS Code extension right here called PowerShell. So we actually just shipped a new GA of this thing, new major version. It's been completely rebuilt for anybody that's used this thing in the past. We have massively improved the stability and debugging performance of the extension. So for those unfamiliar, what this thing allows you to do is essentially use this integrated console as a shared context with your editor space. So if, for instance, I had a new PS1 file here. PS1 is the extension for PowerShell, so I'm just going to change my language mode here to PowerShell. But I can define a variable like $A equals hello WSLconf, and if I run this with F8, I'm going to have that pop down here, and $A will be just available to me now that I've defined that thing by running that line of code. But similarly, I can, for instance, define a $foobar equals, this is another test. And if I go back up here, I'll actually get tab completion on the existence of foobar, right? So this tab completion is actually hooked up to a live language server that's running down here in this integrated console. And this is also going to allow me to debug in real time and see what's happening over here in the VS Code debugging editor. So if I go ahead and show this one here, I'm going to F5. This is actually going to show the way that errors work here. We've significantly changed the error handling of PowerShell to make it a lot more readable in 7.0. So if I were to open up the old PowerShell, you'll notice that, let's say I get child item dash path, not there, right? I'm going to get all this gobbledygook. This thing's really hard to read. It's really this is the bit here that I care about, which is that I couldn't find the path. And all the rest of this is sort of .NET exception stuff that's not going to be interesting to me a big chunk of the time. I'm going to go ahead and run this thing from the start, and we're just going to see this run through. So now, because this is a multi-line script, I'm actually getting the line information, whereas in the past, this was buried here in this line here, but this is actually showing me the line all lined up nice and neat. I've got a red squiggly here telling me what part of the line that the error is coming from. And then I've actually got the error message here with the useful actionable information just below that. So it's a lot more readable. This was a big deal for us. I think we borrowed heavy inspiration from Rust and a couple other languages that have done this really well. But actually, we've done this even better, which is that this is dynamic. So if I run this line inside of an interactive shell and I only have one line as opposed to this multi-line script that I just executed, I'm actually just going to get the string because it knows that this extent here is just coming from just this little piece, and I don't need to go and repeat that down below. So these are little things, but we've seen really strong reactions to folks that say that this has really helped them be more productive in their day-to-day jobs just by being able to skim these log files and big multi-line error messages a lot easier. I'm going to skip this one. So this is actually performance improvements that were made. So if we go ahead and run this thing, this is basically just this is converting to a base 64 string. This will convert from a base 64 string. And so all we're doing here is getting actually the text of this file itself. We're multiplying it times a very large number and then converting it to and from a base 64 string. So we're going to go ahead and execute this thing. Button there. And you'll see that round tripped pretty fast. We didn't hit this error, so I'm going to actually run measure command and then execute this thing again. But before I do that, I'm going to show it here. Back to this directory. Can everyone see the text in this window, or I can probably make this a little bit bigger here? All right, that's giving me hassles. Keyboard shortcuts no good. All right, cool. We can measure command this same script. This is in the old Windows PowerShell. I haven't run this on this machine, so we're going to spell this wrong. Oh, I'm not in the full directory here. Okay. So we're going to measure the output of this thing. This is going to tell us how long the execution of the script takes. So you'll notice this is 3.839 seconds. And, we'll find out if maybe we get a hot start that's a little faster. But it looks like, nope, that's in fact about what it takes. And if I run this with this guy, we got 2.7, right? So this is like pretty significantly faster, about 30% for something that's only a 4-second workload. We have made a massive focus on performance in the last couple of versions. This is one of the things that people often ask, hey, if PowerShell is working great for me on Windows, why would I want to move? And there's a really long tail of performance improvements that have been made that at high scale have significantly improved people's lives. This includes importing CSV files, which we support, taking CSVs into PowerShell objects, um, serializing JSON and deserializing JSON. A number of fixes that have significantly improved, say, download time on pulling files with our web commandlets is actually just turning off the progress bar. Apparently, writing progress often takes longer than actually retrieving files in many cases. But one of the things that we did in PowerShell 7 that's sort of the most potentially transformative is this concept of for each object parallel. And unfortunately, I don't have a super handy demo on this one right now because, again, this is really only going to be interesting with really large data sets and in sort of longer running operations. But basically, in PowerShell, we'll just give a quick example. So this is an array, right? Shorthand for an array. This is 1 through 10. If I want to pipe that through the pipeline, the pipeline is really a core part of the power of PowerShell in that, we're constantly taking these little commandlets, we call them, and composing them together, very similar to the GNU philosophy of composing these small tools together, that do one thing really well. And so, I couldn't say for each object, and this basically says for each of the items on the pipeline, run this script block, right? And so the script block will say, okay, the number is, and I can put in here $underbar, which is the shorthand for each item as it makes its way through. And so, we get this, okay, the number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can imagine that instead of 1 through 10, these are extremely large log files or extremely large, data sets of some kind. We have a lot of DBAs and SQL users that process a lot of data in PowerShell. And so, we added this parameter to for each object dash parallel. And basically, this is going to do each of these executions in a separate run space that gets spun up. And you'll notice that this actually was probably slightly slower, given that a run space has to be spun up for each of these to be executed. So you don't just want to add this, willy-nilly to everything you're doing. But we've seen users say, hey, in some real-world log collection, a script that used to take an hour is now taking 8 minutes with this parallelization. And we allow you to change, you've got this throttle limit that says, how many run spaces you can spin up at a time. I think we default to 5. But this is highly powerful in that it's very, very easy to get started with. Interestingly, we shipped a module called the thread job module in PowerShell Core 6 back in the 6.1 timeframe. And this gives you the start thread job commandlet, but this requires that you sort of manage these threads, and you have to be aware of how you're constructing them and what you're passing to them. With the dash parallel on for each object, we've handled that all under the hood. And as long as you're trying not to edit variables on the fly that are potentially not thread safe, then you're covered in many ways by all the safety checks of this dash parallel. So if you haven't already, give that thing a try, add it to a few things that you use, and I do want to give time for questions. I'm looking at the time here. I got about 7 minutes left. Are questions baked in, or should I go ahead and cede some time here?
We can run a little bit over if you still have some more demos. It sounds like we've got maybe 3, 4 questions.
Okay. I can show this one more, which is just this is and again, I actually chatted with Steve on this one, and he was saying, well, a lot of these WSL users are also Windows users, so they may care about the WPF stuff that's been added back here with .NET Core 3.1. This is actually just us adding the presentation framework assembly, and then we're instantiating this XML node reader, XAML reader, and then showing a window. So I'm just going to execute this thing real quick, and this is just to demonstrate that yes, in fact, we can work with GUI tools. So we've got this initial window. This thing has popped up. I don't think necessarily that this. Oh, you know what? I do know. I know exactly what's in here. but I'm not sure that it's going to work. Yeah, Steve included a joke image that had gone viral a year ago of me on an airplane looking sad that was memed as Sad Joey for the better part of our European conference over the last 2 years. But I think that this is not working, probably because I'm trying to run it from within VS Code, but I do want to give time to the questions, and I know that there are a few of those. So yeah, we can hop back over to that. Are people speaking on these questions, or are we just reading them off the right here?
Oh no, I can go ahead, but yep, they're all in the Q&A.
Awesome.
And I think the first one, well, we've got a couple anonymous questions rolling in, but actually, if we want to start at the top, from Emilio, is there a variable to specify the number of cores to use in for each object parallel?
So not the number of cores, no. I think potentially there's something, there's some Windows API in there to mess with that could set the process affinity, but I don't know that that's anything like that would be exposed on Linux. It's definitely something I want to make a note of as I am taking notes here of something that could absolutely be useful. I'm assuming, this is in scenarios where you don't absolutely want to bork your CPU, getting just plastered over by this thing filling up all of these run spaces. But I can say that, if you set the throttle limit to a number below your set of cores, which again, it defaults to 5, but you could potentially make it 2, we're not going to use more cores than we have run spaces. So, certainly that won't allow you to take advantage of like multi-threading or excuse me, like hyper-threading kind of stuff on, like I can't have 4 run spaces on 2 cores, but I can know that I only have at most 2 cores in use. But yeah, I definitely will take a note to add that.
Cool. Looks like the second question is looking for an update on support for VS Code profile.
I don't know that went away, Tom. I can definitely take a note. If there's anything about that, it's very likely in the github.com/PowerShell/VSCode-PowerShell repository. But I know the folks that own all of that very well, so I will find out. I imagine that's you're talking about your shell profile um, for specific to VS Code, so that you're loading sort of a custom profile based on that host. If it's not called that, it should absolutely still exist, but it may have just been moved to something else at some point in the latest version.
So the next question from Emilio, the for each object parallel.
Yeah, is a substitute of workflows in PowerShell? If so, is it restricted to x64 like workflows? So for those not familiar, PowerShell Workflows was a feature based on the Windows Workflow Foundation, which was a major .NET project that didn't really take off. We took a pretty hard dependency on it with PowerShell Workflows. It did require that a number of, basically if you're running your script, anything that you wanted to be parallelized or checkpointed, it had this notion of checkpointing like long-running tasks, had to be run from within the Windows Workflow Foundation, and that did not support a full set of .NET functionality. And so because of that, folks were only able to take advantage of the parallelization in workflows if they fit within that subset. We got a lot of feedback that the only feature that people loved out of workflows was parallelization, and that they wanted parallelization in general for all scripts. And so we took a very different approach in this thread job module. We don't use the Windows Workflow Foundation at all. We've actually removed workflows from PowerShell since 6.0. And this is a generalized approach that should work with arbitrary PowerShell script and .NET script. So great question though. I can keep working down here.
Awesome.
I'm just going from the top. Yep. I use modules that sometimes step on each other. For example, the get VM command line is available for both Hyper-V and VMware. Can they coexist? And if so, how do you make sure you're using the right one? Great question. So we always recommend to module authors that they use something called a noun prefix in order to make sure that they're basically making their module or their commandlet names across sets of modules. They don't always do that, even in Microsoft and even with VMware, who's a very strong partner of ours, actually. One of the things I do want to note, too, is we worked really strong with Amazon, Google, and VMware in our launch of 6.0. All of them ship PowerShell commandlets in the gallery. We're firmly committed to being interoperable with everybody. 2 members of our PowerShell committee are actually work at Amazon on AWS. So we're we're very, very, like, the VMware guys are great. Those commandlets are generally awesome. So I'm absolutely not talking any trash on them whatsoever. But yeah, you can specify what's called a fully qualified module name and command name. And so basically it's a little bit verbose and annoying, but if you have those two commandlets in the same run space, you can basically specify the module name / the command name, and that's going to give you the specificity of exactly that version. And I think that syntax is even extended, like you can specify a specific version of the module if you have multiple versions of the same module loaded and that sort of thing. So yeah, the fully qualified module syntax, I could probably Google it real quick here just to make sure that I think there's a little bit of nuance to the syntax, but you should be able to find that pretty easily, and I'm happy to follow up if it's not out there. Does PowerShell 7 make the Windows compatibility module obsolete, i.e. it's running behind the scenes now? Yes, so there was a Windows compatibility module that we shipped that did kind of what we now do natively in 7. It actually, the major difference was that module used implicit remoting over the networking layer, which was problematic because we made a security fix pretty recently to Windows that does not allow implicit remoting over localhost unless you're an administrator. So it basically required that you be an administrator in order to use that module. The same time we made that security fix, named pipes got massively improved in .NET Core, and so we use the named pipes layer as a way to do the implicit remoting instead of the PowerShell remoting layer over the network. So it's yes, it's obsolete. You don't have to use that thing. It's going to go the way of the dodo. Just use the PowerShell 7 stuff that's built in. All right, the $1 million question: from which Windows version this PowerShell 6 or 7 will be included in by default? So we're still working in from the outside. We want to be in box. We've wanted to be in box for a long time. The primary challenge is around .NET Core's support lifecycle. So because we ship .NET Core as a dependency within the PowerShell release package, and they are only supported for 3 years in their long-term support, we're unable to ship into Windows because Windows long-term support requires 5 years plus 5 years of extended support. So we're not very close to that 10-year right now, but we are doing things in the next release to make PowerShell significantly easier to install within Windows. That includes shipping in the Windows Store. We're putting together some plans for a bootstrapper that may ship into Windows Server. We may go into the Microsoft download catalog. We're going to try and implement some Microsoft update stuff. So there's a number of things we're turning on to kind of come in from the outside. And then we're also talking to some teams who own semi-annual channel-based releases or SKUs of Windows about our opportunity to ship in just those, given that the long-term support problems are not relevant in that space. So unfortunately, I don't have a timeline. I don't have specifics on exactly when and where that's going to ship. But inbox is something that we're still thinking heavily on and that we absolutely want to do at some point. Question from Aaron on Telegram. And by the way, cut me off at any time. I know we're over time. I'm happy to go over for a little bit, but if folks do want to get me out of here, I'm just
let's do Aaron's question and then 2 more questions on the top.
Sounds good. Question from Aaron on Telegram. In the past, there were still some PowerShell related modules that only ran in non-core versions. Are there plans to make everything work in 7 and beyond? Yeah, so I'm actually going to type out a URL here that we very recently put up to coincide with the GA. So this is highly incomplete at the moment, but this is basically a table detailing the modules that are compatible natively in PowerShell 7 and where and how you can install them. So, for instance, a lot of folks ask us about the Active Directory module. It doesn't work with PowerShell 6 or 7. Actually worked in Windows 10 and Windows Server 1903 or even 1809 and above for a very long time, but you have to install this one specific feature, and that's how you obtain that thing. So we're going to continue adding to that. All the teams for the major modules you care about, we're talking to on like a weekly basis right now. So it's Active Directory or Azure Active Directory. Microsoft Graph is already compatible. SharePoint Online and Exchange Online we're talking to, and those are turning along. The Azure PowerShell modules have been compatible for a very long time. A number of the Windows modules are compatible. There are a couple of the Windows modules that are likely never going to be compatible, just because they leverage APIs that .NET doesn't have plans to bring into .NET Core, like system.web, for the IIS modules, that sort of thing. But we do think that the compatibility layer has been filling a really strong stopgap there, and we've heard really good things from folks that actually don't know that it's running in the background because their stuff is just working fine. So right up at the top, what about optional features? I'm not exactly sure the context of the question. If this is talking about like optional features like feature flags within PowerShell itself, we actually just rejected an RFC based on this notion the other day. Optional features unfortunately grow our testing matrix significantly, and there's some stuff we're trying to do in the medium to long term to decouple some of the PowerShell engine components from each other and modularize PowerShell a little bit better. So there's something that we might be going down that road in terms of being able to remove functionality that you're not using, especially in non-interactive environments. But right now, like pure optional feature flags, we don't have any plans to. But if you have any use cases for them or you feel very strongly, just hop over to GitHub, file an issue. We're always happy to discuss more. And lastly, what is the state of PowerShell 7 on ARM Linux? Is very good. Basically, whatever .NET Core supports, we do as well. I run Raspberry Pi cluster at home. I run PowerShell-based Docker containers on it. They run great. ARM32, ARM64, Alpine. I think actually Alpine on ARM we're not supporting yet. I think that might be one of the limitations, but yes, it's very strong. And then I know this last one, somebody snuck one in here. Shipping Posh 7 with optional features like Windows Open SSH. I don't think we have any plans to do that. Those are sort of decoupled. They're separate features. They work with each other, but I think we could potentially write bootstrapper scripts that help to install and integrate those things. But today we're not planning to put those packages together. And then the last one was PowerShell for Linux will be able to add WMI instrumentation classes that can be used to call objects on Windows targets. So I think the short answer is no. Right now, the answer is, remote into the Windows box and run the WMI query from that Windows machine. There was this thing called OMI for a long time that was a WMI equivalent on non-Windows platforms, but we were never really able to, get the justification to, make all of the commandlets work via this OMI client into the WMI thing. I think we had some proof of concept for a long time, but it was a little bit unstable, and ultimately we decided that it wasn't a huge burden for folks to go in through the remoting layer on WinRM and OpenSSH. So if you do have blockers there or more limitations, like I said, please file an issue. But I am way over time at this point. Thank you so much for letting me go over. I really appreciate everyone's time. It's been a really, really interesting conference, and yeah, thank you everyone. I hope you had a good time.
Yeah, thank you actually for the extra time. I think we're all extremely appreciative of the extra time and demos and one of the smoothest Q&As that we've ever had. So thank you.
Thank you so much.
Yep.
Really appreciate it.
And make sure to flash your social maybe one more time for folks.
Yeah, can I throw it on the chat? I'm just at Joey Aiello across the board. Feel free to DM me on Twitter. Inbox is open. File any issues against us. It's https github.com/PowerShell is all of the great projects that we have. So thank you so much.
That's perfect. Thank you.